Have you ever looked at your hand and thought, what is this truly made of? We think of it as solid, but physics tells us a story that's far stranger, far more wonderful, and almost unbelievable. Today, we're diving deep into the quantum revolution, a journey that reshaped our understanding of reality itself. So, buckle up, because things are about to get weird. Our story begins in the early 20th century, a time when classical physics seemed to have all the answers. But then, a few cracks started to appear. Experiments showed that light and matter behaved in bizarre ways at the smallest scales. This is where giants like Erwin Schrödinger and Werner Heisenberg stepped in. Schrödinger gave us his famous wave equation, which describes how quantum systems evolve. But he also gave us a thought experiment that perfectly captures the absurdity of it all: his cat. Imagine a cat in a box with a radioactive atom. If the atom decays, a poison is released. According to quantum mechanics, until we open the box, the atom is both decayed and not decayed. This means the cat is, bizarrely, both alive and dead at the same time. It's only when we observe it that reality collapses into one state or the other. This leads us to Heisenberg's uncertainty principle. It is a fundamental law of nature stating that we can't simultaneously know certain pairs of properties of a particle with perfect accuracy. For example, the more precisely you know a particle's position, the less precisely you know its momentum, and vice versa. It's not about our measuring tools being clumsy. It's an inherent fuzziness built into the fabric of the universe. The universe, at its core, is a realm of probabilities, not certainties. This was a radical departure from the deterministic world of Newton, where if you knew all the conditions, you could predict the future perfectly. This probabilistic nature deeply troubled many physicists, most famously Albert Einstein. He famously declared, "God does not play dice with the universe." This brings us to one of the most mind-bending phenomena in all of science: quantum entanglement. Imagine you have two particles that are linked, or entangled. If you measure a property of one particle, say its spin, you instantly know the spin of the other, no matter how far apart they are. Whether they're in the same lab or on opposite sides of the galaxy, the connection is instantaneous. Einstein called this spooky action at a distance. He thought it violated his theory of relativity, which states that nothing, not even information, can travel faster than the speed of light. He argued that there must be hidden variables, predetermined properties that the particles carried with them all along. For decades, this was a philosophical debate, but then, a physicist named John Bell devised a theorem that could actually test it. And experiment after experiment has proven Bell's theorem correct and Einstein wrong. The universe really is that spooky. Entanglement is real, and the connection between these particles is faster than light, though it can't be used to send classical information, preserving causality. The next major leap forward was the development of quantum field theory, or CUFT. This theory marries quantum mechanics with Einstein's special relativity. In CUFT, the fundamental building blocks of the universe aren't particles, but fields. Imagine the entire universe is filled with invisible, vibrating fields: an electron field, a photon field, a Higgs field, and so on. What we perceive as a particle, like an electron, is just a localized vibration, or an excitation, in its corresponding field. This beautiful and powerful framework is the foundation of the Standard Model of particle physics, our current best description of all the fundamental particles and forces, except for gravity. It predicted the existence of particles like the Higgs boson decades before it was finally discovered at the CERN Large Hadron Collider in 2012. CUFT describes a universe that is a seething, bubbling cauldron of energy where particles can pop in and out of existence from the vacuum itself. It's a dynamic, interconnected reality that is a far cry from the empty, static void people once imagined. So, where is all this leading us today? The weirdness of quantum mechanics is no longer just a subject for theoretical debate. We are actively harnessing it to build revolutionary technologies. Take quantum computers. A classical computer uses bits, which are either a 0 or a 1. A quantum computer uses qubits, which, thanks to superposition like Schrödinger's cat, can be a 0, a 1, or both at the same time. This allows quantum computers to perform certain calculations exponentially faster than any supercomputer on Earth. They hold the promise of revolutionizing medicine by designing new drugs, creating new materials, and breaking modern encryption. Then there's quantum teleportation. It's not quite beam me up, Scotty, but scientists have successfully teleported the quantum state of a particle from one location to another using entanglement. While we're a long way from teleporting people, this technology is a crucial building block for a future quantum internet, which would be unhackable and could connect quantum computers around the globe. But the ultimate goal, the holy grail of physics, remains elusive, a unified theory. The standard model, for all its success, doesn't include gravity. Einstein's theory of general relativity, our best description of gravity, works beautifully on the large scale of planets and galaxies, but it breaks down at the quantum level. Finding a theory of quantum gravity that can unite these two pillars of modern physics is the biggest challenge of our time. Theories like string theory and loop quantum gravity are promising candidates, but they are still unproven. This quest for a theory of everything pushes us to the very edge of what we know to explore the nature of space and time, the origin of the universe and the Big Bang, and the mysteries of black holes. The quantum revolution that began over a century ago is far from over. It continues to challenge our intuition, inspire our imagination, and unlock the deepest secrets of the cosmos. From the subatomic dance of particles to the grand sweep of the universe, we are living in an age of incredible discovery, all thanks to our willingness to embrace the wonderfully weird world of quantum physics. Thank you so much for joining me on this journey into the quantum realm. If you found this as fascinating as I do, please hit that like button, subscribe for more adventures into the unknown, and let me know in the comments what part of quantum physics blows your mind the most. See you in the next video.